Hello everyone, welcome to Adan. So now we are going to solve this question based on Bowden. As you can see, it has been given that 2500 kg of a dry and saturated steam per hour is generated at a pressure of 15 bar. And the feed water is at 25 degree, coal is burnt is a T50 kg per hour. And the calorific value of coal is given, and we have been asked to calculate the equivalent evaporation and the efficiency of the bowl. So let us see how we can now solve this question. So first of all, if we are given this question like this, so we have to use the steam table. So steam table, if you do not know how to use it, we'll advise you to learn that first. So because you will need to read the steam table and calculate the values of HF as G and HFG from that. So let us see if you have the first thing which you notice here is that you have the steam at dry and saturated of 15 bar pressure. So if you look at your steam table at saturation pressure of 15 bar, you will get that the value of HF is nothing but 844.66 kg kilojoule per kg, and the value of HFG is 1945.2 kilojoule per kg, and the value of Sg is 2789.9 kilojoule per kg. So these are the values. At the saturation pressure of 15 bar at the steam table. If you look at, so that is why I said that you will need to know how to read the steam table. So if you are calculated these well, and the second thing which we need to calculate is at 25 degree Celsius, what is the HF? Because as 25 degrees Celsius, there is a feed water then. So we will need only the HF, which is the enthalpy standard, specific enthalpy of the fluid. HF stands for specific enthalpy of the fluid. So HF at the rate 25 degrees Celsius say, if you look at your steam table, you will get the value as 104.77 kilojoule per kg. So that is how we can find the HF. So why did we find both of this data? Because we need that to calculate how much the energy or the value of the enthalpy of the steam which is the steam is carrying. You need to calculate that in order to compare it with the how much you have supplied from the coal burnt. So if you can somehow correlate that, you can calculate the efficiency of the boiler, because we know that the efficiency is nothing but whatever we have inputted, output upon input. So whatever we have the input upon, whatever we have output divided by whatever we have input. So output is nothing but the mass of the steam, whatever is coming into H minus HF water. So this H stands for the enthalpy, stressing enthalpy of the gas or the steam which we have, and HFW stands for the feed water specific enthalpy. So this basically is how much energy we have, we can get from the steam, and or the steam has, and the input is nothing but mass of the coal which we have given, or mass of the fuel which we have given, into the calorific value of fuel. So this is nothing but total energy which is we have inputted into the system or into the boiler, and this is how much we have got or the output which we are expressing in terms of energy. So output is expressed in terms of mass of the steam which is generated into H minus HL. So mass of the steam which is generated is we have as a 2500 kg per hour, and we have mass of the fuel as a 350 kg per hour. So that both of the units will cancel, so you do not need to worry about the units now. So this is 32,000 kilojoule per kg as your calorific, and you have H you need to calculate, because for the steam, this is for steam. So for steam we have this which is Sg as our H, which goes there. And now we have a dry saturated steam, so we do not need to worry about calculating H. So H can be calculated as HF plus X times HFG. So this is the formula for calculating that, where X is nothing but the dryness fraction. So this is dryness fraction. But in our question, it has been given that the steam is dry and saturated. So if the dryness fraction becomes 1 for dry steam, for dry, X is equal to 1. So that is why we can say that H is nothing but HF plus HFG, which is nothing but Hg. So that is why we have written that H is nothing but Hg, and we have calculated Hg earlier, which is 2789.9. So you can write that 2789.9 minus 104.77. So if you calculate this, you have in your calculator, you will get the values of 59.93% as the boiler efficiency. So this is how you can calculate your boiler efficiency. And the second thing we are required to calculate is nothing but the equivalent evaporation. So equivalent evaporation. So what does it mean to calculate equivalent evaporation? So whenever you compare different types of boilers or different designs of boilers, what you are looking for is how much steam it will generate. So let's say some boiler can generate 10 kg and some can 12 kg or anything. So if you want to standardize somehow the comparison, then equivalent evaporation is used to compare different boilers. Where you will say that how many kgs or how much steam it will generate if the conditions are standard, which are the standard pressure and standard temperature. If the condition has let's say, if the condition is at the rate 1 bar and 100 degrees Celsius of feed water coming, and we have to convert this into 100 degrees Celsius of saturated steam. So let's say how much steam then can you make? How much steam can your boiler make? Is the question here. So that is the equivalent evaporation. So how much kg can your boiler make at these standard conditions? So this can be calculated using again, you need to first calculate how much kg is your boiler making now. So firstly, we have 2500 kg per hour of steam coming from 350. Like 350 is the kg of coal which we have burned. If you divide this, you will get something known as mass equivalent, or equivalent mass of evaporation it is called. So you can just calculate this and it will come out to be something like 7.14. So 7.14 is mass equivalent or equivalent mass of evaporation, you can say that. And if you use this, you can use this here in the equivalent evaporation thing. So just say that mass of like if you are generating steam at 15 bar, then this is how much steam you get per kg of coal, which is 7.14. So this is Me, and you have H minus HF, which denotes again the total energy and which is there, and in the denominator you have 257. So why this 257 is there? So this is nothing but at the standard conditions, how much energy do you require to convert 101 in 1 kg of steam, 1 kg of water to 1 kg of steam. So this is this net energy, which is also called as latent energy or latent heat. So 1 kg of water at 100 degrees Celsius to convert that into 1 kg of steam at 100 degrees Celsius. So this much of enthalpy or energy you need. This is in kilojoule. This much of energy you will need at the standard condition. So this is nothing but the value of HFG. So HFG is also produced latent heat at the, you can check the steam table also at the rate 100 degrees Celsius and 1 bar, you will get this value. So if you put this value 7.14 into H is nothing but we have calculated 2789.9 and minus HF again, that's the same HF which we use in efficiency 0.77 divided by we have 2257. So if you calculate this, you will get something as 8.5 kg. So again, the kilojoule here and the kilojoule here will get cancelled, and you'll only remain with the mass equivalent values, which is nothing but kg of steam per kg of coal. So this is how much your boiler can generate if there are standard conditions. So this is how you can interpret your answer. So 8.5 kg of steam is what your boiler can generate if you have standard conditions. So yeah, this is how you can solve this question. Thank you.